So this is the I'll repeat myself. This is the processing programming environment. It is free to download from processing.org. Just Google processing, download. If you have a Mac at home, if you have a PC at home, if you run Linux, it will work. If you're running a Raspberry Pi, it will work. Whatever your computer is, processing pretty much works on everything. Maybe not some of those old ones back at the room there, but it's good to go on pretty much every computer that you might have. Basically, right here where the cursor is blinking, you are going to compose your programs. All your lovely games that you're going to make and animations and things are all going to start here. So let's get started with how do you make some programs. The first thing I want to show you is comments. Comments are just words that you want to type in to leave some notes for yourself. And I'm going to show you this because as we do a program together, you'll probably want to jot down some notes to remind yourself of things. So you might be like, oh yeah, I want to remember that the order of these numbers is X and then Y, and then width, and then height. And to do that, you'll need to make a comment. So you can't just type stuff in. If you start typing things in, it'll think that's part of the program. So if you wanted to write like this is a comment, like this turns out it's a special word. And so you can't just like suddenly start typing stuff in. But if you put 2 forward slashes, so like beside the question mark or like with the question mark, if you put 2 forward slashes, it'll turn, I'm not sure what color it turns on yours, but a slightly like different color. And then that's okay. You can type in whatever you want as long as there's 2 slashes in front of it, and then the rest of this stuff will be ignored by the computer. So if you want to write some notes today about the program we're making, then go ahead and just type 2 slashes in front. So this is a comment. What kind of comments are you going to leave yourself? And by the way, these will be worth marks because well-commented code is expected if you are a university student, if you are working for Google or working for Facebook or wherever you want to be. There are actually standards upon which you have to perform. And if you don't, you get fired from those jobs. If you're that programmer who's never putting comments in. So what comments are you going to put in every program? First of all, you're going to put in your name. So here I am, Len Peltier, and then, I don't know. I guess I'll put in block 2, 1, 4. And you could put in some more information. I've seen a lot of students make a little to-do list at the top with comments, just like reminding themselves, because we program in 80-minute increments. Usually people don't do that. Usually people, program 8 hours a day, right? So like you're going to have to stop and start your project over and over again. So you might want to remind yourself a little to-do list, like, what did I just finish last class? What problem am I solving next? And so on. So you can use comments in a bunch of different ways. But you can do first. And maybe I'll just make a quick note about what this project is. Our first program. I'll put our first processing program because some of you have done other programming languages before. And technically, a program in processing is called a sketch. So I'm actually not going to type program, I'll type sketch. So if I ever say the word sketch, or you see like open a new sketch in the menu or something, sketch refers to a program. So we got comments, woohoo! We can write words and it won't mess up our program. Is basically what we've achieved so far. All right. Not really what you wanted to see, but it's an important part of programming. So next thing we're going to do, and hopefully, can everybody see this okay? Is it visible, especially folks in the back row? I know, Timothy, it's a challenge there. So good luck. I don't know if you... I'm thinking of taking those computers and moving them over here, by the way. I think it might be useful to put them in this thing. Yeah, is the dark theme bad, actually? I can turn off the lights, it might improve it. Let's turn off the lights. I'd like to have the chill of darkness in here. The dark Lord.
Can you also change the font?
I can't, but don't worry, the programming that'll come up will be nice and bright. I can make it bigger, but the code itself, here, I'll show you an example of what code looks like. First thing we need to do, we're going to make a little drawing right now. A really bad drawing. And it needs to be in a window. We have to have a place for this drawing to be composed, a canvas upon which to paint. So all of your projects, they will live in a window, and to create that window, you use the following, they're called functions. You can think of it as a command, a special word that you type in. This one's called it's surprising, it's size. Like my shoe size is size 10. Size. It's not quite done yet. And you'll notice it's giving you a little error probably at the bottom. Don't worry, don't panic. It's okay. We're just not done. Size implies you want to make a window of a certain size. So you now have to tell processing how big you want the window to be. So the way this works is you type in the name of the function, and then you're going to use 2 parentheses. You know the parentheses, right? Like shift 0, shift 9. And inside the parentheses, you can give it some numbers. And if you typed in the right name, the function should turn blue to indicate, I'm not sure what it is on yours actually. What color is it on yours? Blue? Oh, hey, there you go. It'll turn blue and you'll know that you typed in an existing function. So what numbers do we put in here? So basically we put the width and the height of the size of the screen that we want to create. So I'm imagining that we're going to have a width of 800 and a height of 600. That's just what I chose. And that's measured in pixels, by the way. So I'll say 800, and then to separate it, you use a comma, and then 600. To finish it off, when you're done, it's called calling a function. You put a semicolon at the end of your line. You might wonder, why is that? What? This is so bizarre. So yeah, basically, a function consists of the name of the function, and then some, for now it'll just be numbers, some numbers in parentheses, separated by commas. They'll have specific meanings that will customize that function. So just to make sure it's really clear, the size function opens a window of a certain size. The first number in this set of numbers is the width. The second number is the height. And I'll just make a comment at the end of the line to remind me that it's width, comma, height. And we've made our first sketch. Technically, this is a complete sketch. We can run it, and it will do what we've asked it to do. So I'm going to press the run button. Do you guys see that? There's like a play button just at the top left corner of the screen. If you click play, you'll get an 800 by 600 window that'll open up, and it'll have just a bunch of gray pixels in it. Nothing too exciting yet. But you made a window. Oh yeah. Woohoo! We did it. We did it. If you didn't do it, then if something went wrong, you might want to just double check. Because watch it, all the things that could go wrong. What if I left off the semicolon? What happened? Does it care? It does. If I try to run it, it won't work. But notice that it does give us some feedback if we make a mistake. The bottom is probably red for you. And if you go down and look, it might give you a good error message or it might not. So what does it give me? It unfortunately says unexpected token null. That's not really very helpful. Like what it should tell us is, hey, you forgot the semicolon. But processing isn't that smart. I mean, no compiler is really that smart. It doesn't do a super good job of telling you exactly what the problem is. So use your eyes. It does highlight where the problem is. It shows a little red underline there. And the problem might be there, it might be around there. So just notice where it's complaining, and then just try to troubleshoot it the best you can. We'll talk about how to debug a computer as we go forward. So it turns out semicolon's pretty important. Right now, you're going to think, oh man, what if I forget just one semicolon? What a disaster that would be. My whole program wouldn't work. But don't worry, the semicolon is never really anybody's major problem. You will quickly start remembering to end each line in a semicolon. There's another possibility. It might end in a brace, but we're not going to see those today.
There's a processing period, a line where the mistake are made.
Yeah, like I was showing you how it has an underline. Like if I delete the semicolon and I try to run it, it will highlight it and be like, there's a problem here. It told me, oh look, actually now it tells me a much better error message. Missing a semicolon. Hey, good job. It learned. Oh, it heard me talking about it. It's like I was talking trash about it. It's like really got better. So I'm not sure why this time it did a better job of giving me an error message. But sometimes it's right, sometimes it's wrong. Just do your best. And I'm always here to help out if you're stuck. Okay, we have a window. All right, let's fill it with some pictures of some kind. So I'm going to show you some more functions. And each one of them will be a different shape. Just drawing some shapes. And we also have to figure out how to put them on the screen. So I'll start with the ellipse function. Why the ellipse function? I don't know. I just go with the ellipse. We're going to draw a lot of ellipses this year. Not going to lie. Lots of circles. So ellipse means like a circular-like shape. I don't know if you've encountered this word before. Circles are different than ellipses because ellipses can be like an egg shape. It can be like stretched out wide or stretched out tall. So you can make circles with ellipses. And you have to give it 4 numbers in its parentheses. 4 numbers. So the order, I'll just put in the parentheses and a semicolon, and I'm just going to type out the order of what you need. You're going to give it an x coordinate, a y coordinate, and then you're going to give the width and the height of your ellipse. If you make the width and height the same, you'll get a circle. If you make them different, you'll get an ellipse. So you can choose those numbers, but let me put to you this question. If you want to make it the center of the screen, what do you think its x and y coordinates will be? 0, 0 is exactly how it works in math. 0, 0 is always the center of your graph. In math, that's true. In computer graphics, 0, 0 is not the center of the screen. So you're going to have to get used to this. Oh, thank you so much. Oh, look at this beautiful all-pencil TV plan. Really appreciate you guys doing it a second time. I'm sure it's good. Yeah, Sarah. 200, good guess. So here's the great thing about processing. If you're never sure, you can just do it and see what happens. So I'm going to put in, the first 2 numbers are x and y, right? So let's put in 200, 200, and then I'll just give it a width. I'll say 50-50. Good movie, by the way, 50-50. Funniest movie about cancer I've ever seen. All right, here we go. I'm going to run it. Where's 200, 200? It turns out it's about there. Ooh, interesting. Lots of people holding up their hands. They want to tell me where it is. Who wants to go for it? Both you guys? Ario, go for it. Where do you think it is?
My wild guess is that it's the x and y have to be half the size.
Interesting. 400? 300? Let's see. Did it work? Yeah, we got it straight in the middle. What's going on? Why are the x, y coordinates so messed up? So I'd like to show you now just a graphic, but it looks like Timothy wanted to share it with us. But yeah, and let me show everybody a picture that'll help it. But you're absolutely correct. This is on my website, and you can check it out. Coordinate system. Check it out. Here is the difference between Scratch processing and math. On the left, this is what you're learning in grade 8, or maybe earlier, depending on where you went to school. This is the XY coordinate system. You got your x-axis, you got your y-axis. If you go up, it's positive. If you go down, it's negative. And x and y is sort of the same thing. You go to the right, it's positive. Go to the left, it's negative. That's not how x and y works on a computer. And although Scratch worked that way, Scratch actually edited how the screen works. So your processor and all your computer hardware, your GPU, all that stuff, all understands XY coordinates this way. So the x and y axis are still, the horizontal is x and the vertical is still y. But the y axis is upside down. And the origin is in the top left corner. This is going to be no shortage of annoyance in September. You are going to be putting things in the wrong place. And you're going to be like, why didn't it work? And you're going to get frustrated. And it's just a matter of getting used to it. That's okay. All the first month's projects are designed to be like helping you overcome that thing. Yeah, that annoyance. Eventually, you're just going to internalize it. And one day on a math test, you'll get a question wrong because you're thinking processing or something like that. Hopefully, that's not true. But it'll become second nature to you. And you'll never guess anymore about that kind of stuff. Harry, thanks. Yeah, no problem. Always feel free just to walk out of the room. Just put your name on the clipboard, and then check yourself when you get back. Okay, thank you. So y-axis, it goes down and gets bigger. X-axis goes to the right, gets bigger. And yeah, that's why if you take half the width and half the height, you get the center of the screen. Half of 6 is 3. Half of 6 is 3. That gives you the center of the screen. So there you go. So keep that in mind as we're going to be making whatever it is we're going to be making together. So there we go. That is the ellipse. We can do some other things with ellipses. You can make them bigger or smaller. Don't forget you can change the width and the height. And these don't have to be the same number. If I make the height bigger, then we'll get sort of an egg shape. And you can, experiment with different combinations of numbers there. So there we go. We got an ellipse. Woohoo! Next function we're going to cover is for rectangles. Yeah, you would think it was rectangle. Nope, Dave chose rect. Exactly. Get rect. Get rect. I think that's the reason they chose it. They wanted people to make that joke. So we are going to get rect because we're going to try and make this rectangle, and you would think it would be exactly the same system, right? You specify the x, the y, the width, the height. It is, but check out how this is different. I'm going to make a rectangle at the same place, 400, 300. I'm even going to make it 100, 200 in terms of its width and height. Because it turns out rect uses the exact same meaning for its four numbers. It means x, y, width, and height in that order as well. So just having seen this function, you might think, okay, so it'll draw a rectangle and it'll cover up my ellipse. If only it was so simple. Watch what happens. I'm going to run it. You might have already run it. What? And your confidence in the coordinate system is suddenly shattered and you're like, rage quit, you flip the table, you run out of here, and you just stop programming. No. There is a logical explanation for this, but yeah. It is the same, but rects are drawn slightly differently. Arya, you want to tell us?
Yeah, so for the first x and y coordinates, it's not the coordinates of the center, it's the coordinates of the first point of the rectangle.
Yeah, it's unfortunately not consistent, but as Arya said, the x and y coordinates for rects by default is the top left corner of the rectangle. So if you want to draw a rectangle, you don't specify the center, you specify the top left corner's coordinates. Isn't that annoying? So you're going to discover all sorts of little things. Turns out there is a way to change that. You can make rects drawn from the center, but we won't talk about that today because it's okay. We'll figure it out. So I'll just make a note here. Maybe I'll put for x, y describes top left corner. Oh, I missed the P in top left. And then I'll put a comment for my ellipse as well to say that the xy describes center. I'll spell it the Canadian way, even though it'll get us into trouble later on because it's not spelled the Canadian way in processing, since processing was made in the United States. But that's okay, we'll get there when we get there. So there you go. There'll be all sorts of little details like this as you go forward that you will master with practice. And it's okay. If you get confused at first, remember, you can always just delete it and try again. If it didn't go where you wanted to, you can type in some new numbers and keep on trying. Okay, we doing okay? Nobody's lost faith just yet? Okay, I'm glad to hear it. Not yet, but just wait. Now we're going to do the line. Actually, line's awesome. Line is pretty straightforward. You can't make too much go wrong in a line. The way a line works, I'll just put in my parentheses and a semicolon. I'll make my comment right now. The way the line works is you specify one endpoint with an x and a y, and then you specify the other endpoint with an x and a y. And then it draws a line between those 2 points. So you're going to say I'll say x1, y1 for 1 point, the first point, and then x2, y2. That's going to be the 4 numbers you're going to give it. So the first 2 numbers is the x and y of 1 point, and the second 2 numbers is the x and y of another point. So how do you make a line? And I just want you to think about this. Don't say it out loud. How would you make a line? I'll just comment this out. I want to make a line that goes from, the top left corner of the screen to the bottom right corner of the screen. It crosses the whole thing. Could you do it? Give it a shot. If you can't do it, it's okay. I'll show you the answer. But give it a try, even if you're not sure. So again, with the line function, you want to give it 4 numbers. The first number is going to be the top left corner. The first two numbers will be the top left corner. The second two numbers will be the bottom right corner. Yay! Great. If you got it, that's good. But if you're not getting it, that's okay. Or if you just haven't had time to type it in, that's okay. I'll give you just a second to try it out. I will thoughtfully chew on my apple, which is the archetype of knowledge. Always good. I always thought that was crazy. But it turns out in every Disney movie, whenever a character learns something important, before that happens, they eat an apple. They have a bite from an apple. I thought my English teacher was full of something, stuff. And when she told me that, I was like, there's no way. Then we watched like 4 Disney movies in a row, and I was like, Aladdin, yep. Jasmine eats an apple when she finds out who Aladdin is. You name it, whoever the character is, they eat an apple every time before they're about to discover some important knowledge. I'm going to eat an apple. There we go. There you go. Sir Isaac Newton, the apple fell on his head. Didn't really happen, but somehow Adam and Eve, the apple, just so much. Anyways, how do you do this? How do you make the line? So, thanks. All right, we'll give it to someone else, maybe who wants to share. Thanks. What'd you do? What's your name, by the way? Ian? Thanks, Ian. Go for it. Yeah, 0, 0 is the top left. And what's the bottom right? 800, 600. Yeah, which is the size that we specified. You got it. If you're still not sure about that, if you're looking at that and going, what? Keep on thinking about it. Sure enough, that is 0, 0. And sure enough, that is 800, 600. Because all the way across is 800. All the way down is 600. So watch out. Especially if you're really good at math. I find that sometimes students who are really good at math have a lot of trouble wrapping their head around it. Because they're just so like, yeah, no, I know how X, Y works. And then it turns out to be hard. But sometimes it's fine too. Check out that line going straight through the center though. Ooh, just like piercing the center point of that circle there. Hi, thanks.
Why do you have X1 and X2? What does X2 do?
Such a good question. So here, how do I best do this? So this is the first point, and this is the second point, right? And specifically, that 0 is the first X, because this is XY, and this 800 is the second X, because this is also an XY pair. So that's what I mean by X1 and X2. This is an XY pair, this is an XY pair. That's the first X, that's the second X. The first Y, that's the second Y. So there you go. Thank you so much for asking that question, by the way. So what's your name again?
Francis.
Francis, thanks, Francis. These questions always make the lesson better. And I really appreciate those questions. Because maybe someone else out there has also have the same question. I know somebody does. Because every year somebody asks that question. But sometimes I forget to mention some of these things. I get excited about something. It's just been a while since I was a beginner, so I forget sometimes what I need to mention. So keep asking those great questions, Francis, and everybody else too. So good. Okay, we got lines, we got ellipses, we got rectangles. Let's do a triangle next. Man, if you like line, triangle is going to be your favorite one. Because a triangle is 3 points, 3 XY coordinates. So you just give it 6 numbers. I guess one set of XY coordinates for one corner, another set of XY coordinates for a second corner, and you guessed it, 2 more numbers, another XY coordinate for the third point. And then it'll draw a line and connect them all. So, yeah, tough. Could you make a triangle that, well, actually that line's going to kind of be in the way. Let's make a triangle that sort of goes from the top corner down here all the way to the center and then up to the top right hand corner. So we got a triangle that's sort of this top space in here. Let's make that triangle there. By the way, the function's name is triangle. And so you're going to give it 6 numbers. You're going to give it the x and y of the first point. I'll call it x1, y1. You're going to give it x and y of the second point, which I'll call x2, y2. And you're going to give it the x and y of a third point, which I'll call x3, y3. And that's the pattern. 6 numbers. Oh my gosh. So much. And if you can, try to make it so that we got the triangle that's going to sort of carve out that top area of the screen, starting at the origin, going down to the center, and going up to the top right-hand corner. Yeah, good stuff. And if you're having any trouble, no worries. You're going to have lots of time to practice this out. It's quite, I don't know, bizarre to describe things this way with words and numbers and semicolons are random. So if you're having any trouble at all, that's probably natural, like for most people. So don't expect to just be perfect right out the bat, right out the gates. But here we go. I'm going to give the answer away. So if you got it, congratulations. If you didn't quite get it yet, does anyone want more time?
Yeah.
Okay, I'll back off. I'll eat my apple. Just like a Disney movie, because we're about to learn some crazy thing. Yum. It's not just Disney, by the way. Lots of movies have the apple. Yeah, I gotta say, triangle's the hardest one yet. There's 6 numbers. You're just more chances to get something wrong, so don't feel bad if you're not getting it.
Are we going to do arcs next?
I probably won't do arc today, but I'll leave you to discover about arc in some future lesson.
I read about processing while I was bored.
Awesome. I too read about processing when I'm bored. Sometimes I just read about it when I'm not bored.
Learn about stroke and stroke waves.
Yeah, that's coming up. That's coming up. All right, folks, I'm going to spoil the answer. Sorry if you are just madly searching for the answer, but here it is. So I remember I want to make the triangle so that the first point is at the top left corner, the second point is at the center, and the third point's at the top right corner. That's what I'd like for my triangle. So the top left corner is 0, 0. The coordinate of the center is 400, 300, just like we talked about before. We have the ellipse at the center, right? Technically the rect's at the center too, I guess. Then it needs 2 more numbers, that last point. Good guess, but it's not 800, 600 because the y at the top is actually, Sarah, go for it. Or sorry, Vanessa, go for it. 800, 0, yeah. Oh, isn't it weird? 800, 0. I'll just run it and I'll just explain why it's 800, 0. There it goes. There's our triangle at the top. So the first, here, maybe I could split screen it. I don't know, have a good way of doing this. But let me grab my ruler. So 0, 0, that's that corner. 400, 300 is the center, same as the center of my circle, right? My ellipse. And then 800, 0, how the heck is that the top corner? If you struggle with that one, remember, x is 800. That's the x coordinate of the last point, right? So that's all the way to the other side. And 0, it means the top of the screen. Because the y-axis is upside down. So it's going to start at 0 and it increases as it goes down. There you go. And then it just connects those lines and fills the center. There's a triangle. So you can have lots of chance to practice these. And if it didn't quite make sense this time, keep on trying in the different activities that we do. And you'll find that you'll probably come up with more questions if you don't get it. And just ask those questions. I'll come over and help you out. Could be asking me, could be help. Another student might be helping you out. Whatever you feel comfortable with. All right, so now I feel pretty happy. We have ellipses, we have rectangles, we have lines, we have triangles. I think we have all the shapes we need for the first project, but they're all gray and white and black. They're pretty boring colors, right? We'd like to have some more variety in our colors. So I'll show you how you do color now. So it turns out you color shapes with 2 different functions. They had to make it hard. You couldn't just have one thing. But basically, you can color the inside of a shape, and you can color the outline of the shape. For lines, lines are just outlines. There's no inside to a line. So that's not true for lines. But for everything else, there's an inside which is called the fill, like Dr. Phil, but spelled F-I-L-L, like you're filling the center with paint. And then the outline is called the stroke, which I'm not sure where that comes from, but in a lot of programs like Photoshop, Illustrator, the outline is called the stroke. So I think it's an industry standard term. I don't personally use it, but I use it for processing, so I guess it's good. So how do you do it? So you basically use the function to select the color you're going to use, and then you draw the shape. You might think of fill as a verb, right? Like, fill this triangle with pink, or something like that. But that's not how it works. Fill is the function that's used to select the crayon out of the crayon box, if you will. So you do it before you draw your shape. You choose your fill color, you choose your stroke color, and then you draw your shape. So it always comes first. And then whatever color you've chosen stays the color you use all the way till you change it. So if you choose pink and blue, it's going to stay pink and blue unless you put it back to something else or switch it to something else. So I'll do it right now. So I'm going to do it right before my ellipse, so you can see what happens. So I'm going to press enter. I'm going to give myself some space right after size, and I'm going to choose stroke. And let's just start with one number. There's two ways to do this. You can give it one number or three numbers. We'll start with one number. I'm going to give it a stroke of 0, sure. Actually, it's already 0. 0 means black. When you just give it one number, it means black. And if you give it 255, it means white. And anything between is a shade of gray. So the programming joke is, how many shades of gray are there? And of course, the movie is like 50 Shades of Grey, so it's like, it's 50 shades. No, there's 256 Shades of Grey, and I can't wait till that erotic movie comes out about programmers called 256 Shades of Grey, which is like, it's like, I don't know, probably like the awkward story of some nerd trying to like fall in love with a girl or something. I think it'd be fantastic. Or a boy, I suppose. Could go either way. So we'll see if that movie ever makes it to Netflix. At the moment, not so much. But we can type in a number between 0 and 255, and it'll give us a shade of gray. You might wonder, wait, I thought you said 256. And the choices are between 0 and 255. But 0 counts as a choice. So in total, there are 256 choices. So 0 to 255 is 256. So if I put in it's pretty boring if I put in 0 because it's already 0. So I'll put in 255, and you can see that all the lines turn white because 255 is white. And if I put in, say, 120, you'll see they all turn sort of a lighter color gray. And if I put it at 0, they all turn black. Yay! So if you give any sort of function that expects a color just one number, then that number represents a shade of gray. 255, 0 to 255 gives you a shade of gray. 0 is black. Oops. 255 is white. So that's great. It turns out you can also give it 3 numbers. Yeah, oh, weird, yeah. So weird things happen if you go outside the range of 0 to 255. You can get yellow and blue. So why is that? Don't worry about it. It's just unexpected behavior, so it does some weird things. So try to keep yourself within 0 to 255. However, you can give it 3 numbers. So I'm going to just type stroke again. And this time I'm going to give it 3 numbers. If I give it all the same number, it's going to be sort of the same thing as the shade of gray. Like if I give it 3 zeros, it's going to be black. If I give it 3 255s, it'll be white. But what these numbers represent are the red, green, blue, RGB, red, the green, and the blue values of a particular color. So you could type in different values in here to mix shades of red, green, and blue. It's a little bit different than paint. If you're an artist, you've done painting before, you kind of mix your colors together. Paint mixes differently than light, so you'll use different colors than in your art class. But say if I put 255, 0, 0, what color do you think I'm going to get? Red, that's right, because I've maxed out how much red I have. I have 0 green, and I have 0 blue. So if I run this, all my lines will turn red. Beautiful. Beautiful. Thank you for that. That's lovely. Well timed. So there it is. And if I max out this one, I'll get green. If I max out this one, I get blue. You might wonder, well, what if I wanted, like, Gryffindor Scarlet? Like, if I want, like, a really specific color. So, Ario, you're going to mention the color selector?
Yeah, the color.
Yeah.
You can search up a color picker online.
Oh, you can find one inside of processing. Check it out. So if you're like, oh, I want a very specific color, then watch this. I'm going to bring this down because you can't see it. Do you see the menu up here? It's got a lot of cool options. File, edit, sketch, debug, and then tools. Tools. Do you like tools? I like tools. If you click on tools, one of them is the color selector. And so you can open up the color selector. You might have seen this type of thing before. So you can go and select the color. You can kind of scroll down the rainbow. And maybe I'm looking for 80s blue. I don't know if you know 80s blue, but in the 80s, everything was like blue and pink. And it's like teal, like kind of blue, like really bright teal. I don't think it's technically called 80s blue, but I'm going to call it 80s blue. So if I want that particular color, then check it out. It gives me a whole bunch of numbers. We'll later talk about what HSB means and what this hashtag thing is, but there's the RGB numbers of that color, that exact shade of blue. If that's what I'm looking for, I can type in 0, 236, 255. And then, you never have to kind of guess what color it's going to be. If you didn't want that blue, if you wanted yellow, oh, look at yellow. It's 240. This one is 224, 255, and 0. So you can kind of go around and change things up. So I'm going to go with 80s blue.
You can use the hashtag thing.
Yeah, there's a bit of a story to that, so I'm going to hang off on that for a bit. But you're right, there is, and we could actually use the HSB numbers too. But I'm going to just take these numbers here, 0 to 55, and I'll do 255 as well for that one. So zoom out. I picked my color. You go ahead and pick your color. Wait, I forgot what it was. Was it these two? 255. So if I run that, do I get my nice blue? Yeah, I get blue. All right. Okay, I'm good. I'm happy. So next, I want to not have the fill color be white. I want to change the fill color. So same story. I can type in fill. And again, I can give it one number or I can give it 3 numbers. One number means a shade of gray, 0 being black, 255 being white, and something in between being some shade of gray. Or you can give it 3 numbers, RGB, red, green, blue. So I'm going to give it a nice pink color because I like the 80s. I guess I don't actually really love the 80s, to be honest. A lot of bad things happen in the 80s, but, I like the look of the 80s aesthetic is what I enjoy. So apparently that's 255, 0, 255. So I'm going to put that in for my fill color. You can choose whatever fill color you want. Yours does not have to be themed after the 80s. So I got blue, outlines, pink, fills. Blue strokes, pink fills. Seems good. Seems good. I'll mention one other thing. You can also change the thickness of the stroke. If you would like to have a wider outline, then you can use the function called stroke weight. But watch out, beware. Big warning sign here. Stroke weight, you have to spell it correctly. And this is actually the first time we have to do this. I mean, you have to spell stroke correctly and all that stuff. But stroke weight is a bit of a dangerous one because stroke weight is one word with a capital W in the middle of it. So watch out for that capital W. Stroke weight looks like this. And then you give it just one number. I'll give it 10, for example. And this is the width of the outline. This is the width in pixels. So check it out. I do my size. I then give it some stroke and fill choices and a stroke weight. And then I draw my shapes. So then I get all my shapes drawn with those colors. Yeah, Chelsea, thanks.
You know it would be faster to just copy the color code instead of it works.
Oh, you mean the hashtag?
Yeah.
Yeah, there's a bit of a story for that, though. But we'll get to that story later on. But if you want to do that for now, that's totally fine. I don't mind at all. Okay. So, we're doing okay. We're doing okay. I hope you're doing okay. I'm doing okay. Are you doing okay? Yeah, all right. So, yeah, we are amazing artists. Look at this beautiful piece of art we've created, right? These pink and blue triangles are just ready to go to auction. Millions of dollars ready to be earned here, I'm sure. Yeah, what about if you wanted to color that rectangle differently, though? What if you were like, no, I want to make a black and white rectangle or something like that? Yeah, Ian. Yeah, you got it. You would need a separate stroke and fill command, which you could copy and paste if you were feeling so inclined, or you could type it in depending on how you feel. And where would that go if you wanted the rectangle to be different? Well, you would go right before the rectangle. So then I could type in or copy and paste your choice there. Oh, that's my comment. I'll bring it up. Oh. So I can go in right before my rectangle, I can type in separate stroke. So maybe I want a white stroke, 255. I want a black fill, 0. And I'll be like so happy. I'll be like, okay, good. My rectangle's good to go. What color will my triangle be? Will it be black and white or pink and blue?
Black and white.
Two different opinions out there. Two possible choices. Let's find out. I'll run it. We'll see.
Oh, wait.
Turns out it's black and white. Why?
Because does the new line update it?
Good question. So it's actually not the line.
Okay.
So this is very confusing. So let me do my best to explain. Whenever you call stroke and fill, it's like you're picking the crayons out of the crayon box, and those are the crayons you're going to use until you tell it to do something different. So first we pick a black crayon, but then we quickly switch to a, blue crayon. And the fill is a pink crayon. And then we draw the ellipse, so it's pink and blue. But then we switch to a white and black crayon, we draw a rectangle, it's white and black. But for line and triangle, we're still holding the white and black crayons. Is a good way to think of stroke and fill. It's like selecting the colors you're going to use, and they're just, until you tell it differently, it's going to keep on using those crayons. You know, to speak metaphorically. It's not actually crayons going on inside of here. I hope no one goes home and is like, Mom, I found out the secret to computers. There are crayons inside. No, it is not. It's just a metaphor. But that's the idea. Once you've selected your colors, it'll keep on using those colors all the way to the end of the program. And you can just switch it up every once in a while to color things differently. There you go. There's your awesome new information. Well, you know, we've done a lot today. We're almost out of time. We got about under 10 minutes left. We made a really ugly picture. Sorry. Again, I'm not an artist. I do my best. But you're going to be making a lovely picture. You're going to be making a lovely picture. This is the picture I'll ask you guys to make. You can get started on it today, but I would not recommend doing it for homework if you want to get ahead, I guess you can. This is the picture I'm going to ask you to draw. Now, you don't have to get it exact, but you do got to get it pretty close. If you don't get the exact shade of yellow or blue or purple, it's okay. And if you don't get it, exactly lined up, exactly on the right places, that's okay. But try and get it as close as you can. And that's going to be an exercise that will help you not only practice with the XY coordinate system, which I entirely admit is weird and confusing. It'll also give you a chance to practice with your functions that you've learned today. This is entirely made up of triangles, rectangles, circles, and lines. It'll also give you a chance to practice with fill and stroke. And putting them in the right order to make this all work out. There is a little bit of information that I've left out, and that is how do you use the layering of processing? Like, how does this concept of layering help you out? Did you notice that there was sort of this shapes getting drawn on top of each other when we were doing this? Kind of maybe ugly in some ways. On our program it definitely was ugly. Where did it go? So in the code, the first thing that I draw is the ellipse. Then I draw the rectangle. Then I draw the line. Then I draw the triangle. And I did that on purpose to make them overlap so that you can see the ordering. The first thing that you draw gets put in the back. Or you could just say it gets drawn on the screen, and the next thing you draw is going to get drawn on top of that. And then the third thing gets drawn on top of that. And the fourth thing gets drawn on top of that, and so on. Things get drawn on top of each other. So that's both good and bad. You have to be careful, because if you draw your mountains first in this picture, your mountains are going to be on top of... Oh, actually, sorry. If you draw your robot first, then your robot's going to be underneath your mountains. So you got to think about what you're going to draw first. Second of all, this is actually pretty useful. I had a student once ask me, Mr. Pelche, I got this. I figured it all out. I just can't figure out, how do you draw a Pac-Man shape? How do I draw a shape that looks like Pac-Man, that's like a circle and has like a piece of wedge cut out of it? Exactly. You just draw the circle first and then draw the triangle on top of it. Another student once asked me, Mr. Pelche, how do I make an M shape? They saw this mountains, they're like, can I make an M? Yeah, it's just two triangles. But the stroke and fill are both set to the same color so that you don't see them overlapping. And you can't even tell which one did they draw first. Who knows? Who cares? You just draw two on top of each other and they just will merge together. The circle underneath the robot here, this wheel, is not a semicircle, although you can draw semicircles. It's just a circle drawn first and then the body drawn on top of it. And check out these lines. How long are they? I don't care, because you could just draw the circle on top, and underneath they might be like different lengths and all that kind of stuff, so you don't have to worry about getting it exactly perfect. You can just cover up your mistakes. These lines, like how do I get that exact corner? Don't worry about it. Just make them all come out of the center of the circle. Just make them kind of come out of the center and then draw the circle at a certain size and so on. And you're just going to do your best to try and make that happen. If it's not exact, don't worry too much. Don't spend hours and hours calculating where the exact pixels are. But do try to make something like this. Now, usually I give this as an assignment, and then I also offer that as your 9 out of 10. You draw that picture, you got your 9 out of 10. It's quite a bit of work as it is. But often I'll say, if you want to go above and beyond and really earn that 100%, I'll tell students, you could do something better than that. If you do something better than that, 9 out of 10 means you did fantastic, really great. But 10 out of 10 means you went beyond. You went and did something really cool. And I always give that offer. And then people hand in the most ridiculous things. And I'm like, oh my gosh, I can't draw that with my hand and a pencil. How did you do that? So actually, I don't think I have it quite ready to go. Oh no. But maybe next class I'll start off with showing you some of the crazy things students have handed in the past. And you can be inspired to make something cool too. Wait, do I have it? Let me see. I bet I could find it, but the bell's going to go in 5 minutes, so I probably won't be able to find it.
How much time are you going on this project?
So usually I assign 2 classes. And if you're going to do something crazy, you might need more time than that, but you can take it home for homework. There'll be a weekend. Oh, and by the way, if I assign 2 classes, so Thursday will be one day, and next week on Monday will be a day to work on this. The project is never due at the end of the second day if I give 2 days. It's always due the following class. And that way if you don't finish, if you need to, you can take it home for homework. So there'll be some time to do it. Here's one problem I can see happening. Somebody might be like, oh, I'll go save this picture and then I'll look up how to draw a picture to a screen. So just be aware, because I've had students do that. That's not really the point of the exercise. I don't really care that the robot gets shown, but yes, you could download this file and then learn the image function, which then draws it. But you then circumvent the actual value of this exercise, which is getting used to the XY coordinate system and learning the function. So, although that's pretty funny, I heartily laughed when the student did that. They also did the assignment the honest way too. So make sure that you know that's not a loophole that gets you around it. And second of all, I could see some students maybe going home and getting this project done tonight. You're a go-getter. You want to make a great first impression. You're just really bored tonight and you got nothing better. I don't know, whatever your story is. If that's the case, that's okay, but do be prepared to come to class to still do work. If you want to do that, that's okay, but then when you're in class, you still need to be doing programming work. So if you don't look forward to having to set a new project for yourself or do extra work, then don't go ahead of time and get stuff done outside of class time and then come back and play Minecraft in class. occasionally I have students like, they're not allowed to do Minecraft at home, but they're allowed to do homework, so they go home and do their project, for homework, and then they come here and expect to play games, and no, it's just not how it works. So just be aware of that. There is going to be a sketchbook project that we're going to be working on, or maybe a group of projects. So that will give you a chance to work on sort of your own projects if you'd like. Or if you are going to do an extra great job on this project, you're like, yeah, I want that 10 out of 10. I'm going to make a cool picture of Mario or something. I don't know what it's going to be. Then sure. But always make sure you have something to work on in class, because while we're working on a project, that's the goal. So I just want to put that out there before we end today. There it is. That's it. That's our first program. We drew an ugly picture. Next two classes, you're going to draw a less ugly picture. And maybe even a beautiful picture. And I look forward to seeing what you create. On Thursday afternoon, I guess, first day in class, I'll have some old pictures to show you that will blow you away. There will be audible gasps as you see some of the things that people made. Thanks so much, folks. Have yourselves a good day. We'll see you on Thursday.
Thank you.
Yeah, for sure. Ario first.
What is that?
Yeah, I don't have a good definition right now. I'll tell you more next time. Yeah, usually I just give like, if you go above and beyond, you'll get that kind of. Otherwise, like 9 out of 10 is, I think it's pretty great for just kind of reproducing what I already got. Yeah, there you go. Oh, sorry, question? Oh, yeah. You can save it, and save it to your My Documents folder. Perfect, thank you.
Grades gonna pop out.
Did it freeze? Did anybody else's computer freeze? Over in here? Yeah?
Mine just, wait.
I'm so sorry to hear that. So I guess it's not scratched. Well, that's not good. Because that means the computers are causing some problems. So we'll try and resolve that as quickly as possible. If it's broken, you know what? I'll just put the code that we did today on my website. You don't have to worry about having lost the code. And there's nothing you can really do about it. It's dead. You just have to, I'll just hold this and restart it here. It'll just shut off after 5 seconds. Hey, so sorry that happened to anybody whose computer died in the middle of the lesson. Again, I'll put the code on the website with all the comments and everything so you can download that. Save it, just go to the file, save as, and save to your documents folder. You can name it whatever you want. That's not a disaster. I'm not going to ask you to put it in, but it does give you sort of your list of functions you're going to use. So it might be disadvantageous, but like I said to those other students who lost their project, I'll put it on my website, the stuff I just did. There'll be a YouTube video as well. Oh, I should probably turn off that YouTube video. I'm still recording. Anybody who's still watching this video, I am impressed that you stuck with it the whole way. Like and subscribe.